Welcome to another tutorial on TwinCAT PLC automation from ControlX Engineering. Previously, we did 3 tutorials on motion control, and in part 3, we integrated a Beckhoff server drive into our TwinCAT project. If you have not seen those tutorials, then please do check them out from this playlist. In today's tutorial, we will look into integrating and controlling a third-party EtherCAT server drive into our PLC project. Today, we'll be demonstrating the integration of an EtherCAT server drive from LinMot. So let's get started. LinMot is a brand owned by the Swiss company NTI AG, with its headquarters located near Zurich, Switzerland. It's a global manufacturer of tubular style linear servo motor systems and focuses on linear direct drives for use in industrial environments. LinMot manufactures a complete line of linear motors, guided actuators, servo drives, and MagSpring branded constant force magnetic springs. LinMot linear motors provide extremely high speed, long life, complete controllability, long strokes, and peak forces up to 600 pounds. LinMot controllers support many connectivity options like analog, digital, serial, CAN open, as well as many industrial fieldbus protocols like Profinet, Ethernet IP, and EtherCAT, which makes it easy to integrate with most PLCs. For this tutorial today, since we will be integrating with our Beckhoff PLC, we will be using the EtherCAT controller model of the servo. To get started with any device, it is best practice to review the product user manual or installation guide. This page from the user guide shows the typical servo drive connections. This model requires a 72-volt source for the motor supply on connector X1, as well as a 24-volt source for the drive electronics and logic controller on X4. The linear servo motor connects to X2. This is a three-phase motor and requires UVW and ground connections. The communication cables plugs into the two RJ45 connectors marked X17 and X18. This is where our EtherCAT cable from the Beckhoff IPC will be connected. Since this controller has STO inputs for machine safety, the external safety is wired into X33. This page shows the power supply and grounding connections, as well as the recommended wire sizes. The nominal supply voltage for the motor supply is 72 volts DC, and the possible range for this model is from 24 volts up to 85 volt DC. The power source must be able to supply at least 6.5 amps. This can come from a battery or an AC to DC power supply. Similarly, the nominal power supply for the logic supply is 24 volts DC, and the power source must be within the range of 22 to 26 volt DC. To ensure safe operation, it is a good practice to ensure all system components are well grounded to protective earth or PE. This means that the LinMot servo and all control system components must be connected to the same ground. Let's set up the controller with the Beckhoff PLC. For this tutorial, I'll be using my CX5140 IPC, which will be our EtherCAT master. The LinMot C1250 will be the EtherCAT slave, and this will be the linear motor that I'll be using today. And these are the rest of the connections that are required to run this servo. Before we can learn how to integrate the LinMot servo into TwinCAT, we need to understand the concept of ESI file. ESI stands for EtherCAT slave information and is a file that provides crucial information about the slave device to the master. It contains information about the device's object dictionary, which helps the EtherCAT master format commands and display the data correctly, since it contains the indexes, sizes, data types, and descriptions for each object defined in the file. ESI files are crucial for configuring and identifying EtherCAT devices within the network, ensuring proper communication and data exchange between the controller and the slave devices. The TwinCAT EtherCAT master needs the device description files for the devices to be used in order to generate the configuration in online or offline mode. The device descriptions are contained in the ESI files in XML format. These files can be requested from the device manufacturer and are made available for download. This is the I/O node in TwinCAT Solution Explorer. From here, we can manually add or automatically scan the physically connected hardware like I/O terminals, couplers, drives, etc. If the EtherCAT configuration is created online through scanning of a physically connected EtherCAT device and no corresponding ESI description file is available for the slave device, the system manager will ask for, via a dialog box, whether the description stored in the device's EEPROM should be used. The system manager needs this information for setting up the cyclic and acyclic communication with the slave device correctly. If the ESI file is not available, then TwinCAT will prompt you with a message box stating that a new device type was found. As you can see, I performed an online scan and it detected the LinMot servo, but because of the missing ESI file, no useful objects are available and this configuration is not usable. To correctly set up the slave device, the corresponding ESI file must be made available and the configuration process should be repeated. For LinMot, the ESI file can be downloaded from this link on their website, and the ESI XML file must be manually copied to this location in your TwinCAT XAE installation folder. When TwinCAT XAE is first started, it loads all the device ESI files from this location on startup. If the XAE is already open and the ESI file is then copied in the TwinCAT folder, then the device descriptions have to be manually reloaded by clicking on the TwinCAT menu item and selecting EtherCAT devices, then reload device descriptions. After the ESI file has been copied to the specified folder, we can remove the device and repeat the configuration by performing a scan again. As we can see, this time TwinCAT recognizes the device and designates it with the label drive instead of box. It also uses the information in the ESI to populate the transmit and receive PDOs or process data objects. That will be used for notifications and controlling the drive. In addition, since TwinCAT recognizes the slave device as a drive, it is now asking whether the drive should be appended to the motion node in NC or CNC configuration. For our application, we'll select NC configuration and click OK. The new LinMot drive is now appended to the motion node as an NC axis and automatically labeled as axis 1, since this is the first axis we added to the configuration. Let's double click on the new axis and check out the settings tab. We can see that axis 1 is automatically linked to drive 1 in the IO section. Our LinMot servo is now set up to work with TwinCAT. By linking it to a referenced axis, we can have full control of the axis programmatically from the PLC. Now that we understand the process, let's hop onto TwinCAT and Andrew will walk us through the integration process. Off to you, Andrew.
Hi, this is Andrew, and today I will be demonstrating how to integrate a third-party EtherCAT servo drive from LinMot into our TwinCAT project. This will be an exciting video, so let's jump right into it. Since this is a motion control tutorial, I have opened our training project from our previous motion control tutorial. It has all the necessary function blocks that will be required to move the axis in position mode. We had set up all the functionality in a CFC program. We had also created an HMI to help test the motion controls. If you haven't seen this video, be sure to check it out. The link should be on the screen and in the video description. Okay, as you can see, I am already connected to the target system, which is our CX5130 IPC. So we can go to the I/O node, and since we're already in config mode, we can perform an online scan. TwinCAT will scan the EtherCAT adapter for any connected slave devices. Since my LinMot servo controller is connected to the X001 port, I will leave that box checked and uncheck the others. TwinCAT discovered the device, but it doesn't have sufficient information about it, and is asking if it should use the online description from the device EEPROM. Let's see what happens if we say yes. This doesn't look good. Notice the question mark next to the device, and it named it as a box and doesn't recognize it as a drive. Also, there are no usable PDOs, and nothing got added to the motion node for us to use. This is because of missing device description file, or ESI file, that Akhil explained earlier. In order to get this device working, we will first need to get the ESI file from the manufacturer and repeat this process again. I will go ahead and remove the device for now. I have already downloaded the ESI file from their website, and let's copy it to the correct location in the TwinCAT installation folder as shown on the screen. Currently, there is no ESI file for LinMot, which explains why the device was not recognized by TwinCAT. I will now simply move the file to this folder and close the window. Meanwhile, since the XAE only loads the ESI files on startup, I will now do a manual reload of the ESI files. Now I'll do an automatic scan again. This time TwinCAT recognizes the LinMot servo as a drive and is now asking us which configuration to use. Select NC configuration and press OK. Now we can see all the transmit and receive PDOs for this drive. If we expand the drive, it shows them organized into input and output categories characterized by the yellow and red icons. Looking at the motion node, we can see a new axis called Axis 1 has been added, and it has also been linked automatically to Drive 1 in the I/O section. I'll go ahead and activate our configuration. Hit OK to put the PLC into run mode. And we're all set. Looks like I'm getting some position feedback from the servo. This servo has an incremental encoder, so it does not give absolute position. On power up, it will report the current position as 0. Therefore, we will need to physically move the actuator position to the desired home position and then 0 the position manually. This will be my home position, so I will set this position as 0. Now I will move the actuator to the other extreme end and note the feedback position. Looks like the total travel is 172.8 millimeters. Let's enable the controller and try some manual move commands. We can hear the humming of the servo as it is trying to hold the current position, now that it is enabled. Let's give it a target velocity and ask it to go to 0 position. Okay, that's good. Let's try 170. We're back at position 170. Let's head over to the Functions tab and try some built-in motion profiles. Let's try the reversing sequence. That was fun. Now let's get serious and control the actuator from the PLC. But first I'm going to remove the controller enables. Let's head over to the Settings tab. Notice that we have not linked this axis to the PLC yet. So let's go ahead and do that. Now we can activate the configuration. Okay, new configuration has been activated and PLC is in run mode. Let's go back to the PLC project and open the HMI from the visualization folder. I'll pin the NC and HMI pages side by side, and now we can go online with the PLC. Let's enable the axis and try some move commands from the HMI. We can see from the NC page that the axis is fully enabled. Okay, let's have some fun. Well, that's all for this demo. We successfully linked a third-party EtherCAT slave device from LinMot and integrated it into our TwinCAT project. Hope you had as much fun as I had, and hope to see you guys again in the next tutorial. Back to Akil.
That's all for today's video. If you have any questions or suggestions about today's video, please leave them in the comments below. If you found this video helpful, then please consider subscribing so you don't miss out on future tutorials. As always, thank you for watching and keep innovating.